Okay, so part 2, diagram not drawn accurately, ABC is an isosceles triangle, work out the area of the triangle. Okay, so we've got two angles, and because it's isosceles, we know that there is a line of symmetry here, and that line of symmetry gives us two nice right angled triangles. This will be 6, and I'm now going to work out this side here. Because we've got a right angled triangle, we are not using the sine or the cosine rule. Let's not overcomplicate things. We're using just normal SOHCAHTOA. Oh, sorry, I should say what we're working out. I'm going to work out AB here. So we've got this is the adjacent because it's next to, and this is the hypotenuse because it's opposite our right angle. So adjacent and hypotenuse. So we're using cos, and we want the hypotenuse, so we're doing adjacent divided by the cos of the angle. So our hypotenuse AB equals, what do we say, adjacent 6 over cos, and the angle's 54. So we'll grab our calculator now. We've got 6 divided by cos 54, and that gives us 10.207897. I'm going to want to use that later, so shift store, pop it in A. Now that we know that this side here is 10.2 and a bit, we can now work out the area of our triangle, because to use the area formula we need a sassy triangle, side, angle, and this time we're going to be using the whole 12 centimeters. So area, so that's half A and B, so it doesn't matter which way they are, times and the angle in between. So I know it says sine C, but that's the angle that makes it a sassy triangle, so that's going to be our C in this case, sine 54. Okay, so 0.5 times the answer that we got, which we saved in A, times 12 times sine 54. So that is 49.54974914, correct to 3 significant figures. So that's going to be 49.5 centimeters squared. Okay, diagram not drawn accurately. The diagram shows triangle LMN. Calculate LN. So that's what we're after. Give your answer correct. Okay, now this one is a little bit annoying, because if we were going to pair up opposites, we've got side and opposite angle, side and opposite angle, side and opposite angle. So actually we can't directly get to X because this isn't a sassy triangle. We'd need this angle here, and if we work out that angle there, we'd need this side here. So the only thing we can work out to begin with is this angle here, NLM. Okay, so to do that we can use, because we've got pairs of opposites now, we can use our sine rule. Because we're after an angle, that means that the sines go on the top of our fractions. So we end up with, let's go with the pair that we know, sine 136 let's just call this y so we don't get confused. Sine 36 over the angle side that we know, 15.7, times by sine y over, and the opposite side is 12.8. Now when we rearrange, we would end up with sine 136 over 15.7 times 12.8, and that would give us sine y, but we want to which would be a number between -1 and 1, but because we're trying to find an angle, we're going to dump all of that into sine to the -1, and that will give us the size of angle NLM or MLN, whichever way around you want to go. So let's go shift sine to the -1, let's whack our fraction in there, sine 136 over 15.7 times 12.8, and that gives us that it is 34.49578985 degrees. Let's store that, shift store, work in A again. now that I know this angle, I can, we want this side here, so we're not quite there yet. I'm going to have to work out angle, in a different colour. We're going to have to work out this angle here, which is easy enough. That's angles in a triangle. So that means NML or LMN. To work out that, we are going to do 180 minus the angle that we knew, 136, plus the angle we've just worked out, 34.4 ... Okay, so 180 minus 136 plus alpha A, the answer we just got, means that it is 9.50421014.8 degrees. Let's save that, shift store, let's put it in B though so that we don't wipe over what we already had, just in case. Now the last thing that we can do, now we've got a sassy triangle to work out x, because x is opposite the angle we've just worked out, and we've got the two sides either side of it. So now we can use our cosine rule. So x squared, or LM, this will be ln squared to begin with, is going to be 15.7 squared plus 12.8 squared minus 2 times 15.7 times 12.8 times cos that angle there, the 9.5, blah 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 blah. Okay, so if we whack that into our calculator, 15.7 squared plus 12.8 squared minus 2 times 15.7 times 12.8 times, excuse me, cos, and we'll put alpha b in there because that's where we stored the angle that we just found. That gives us 13.92696653. That's x squared though. It feels like it might be right, but if we think about it, this is a very small angle, so this has got to be a very short side, in fact the shortest side of our triangle. So x is going to equal the square root of our answer, which is square root answer 3.731885117. Correct to 3 significant figures, that's going to be 3.73. Okay. VABCD is a solid pyramid. ABCD is a square of side 20 centimeters. The angle between any sloping edge and the plane ABCD is 55 degrees. Calculate the surface area of the pyramid. Give your answer to correct to two significant figures. So, what we do know, because it's a square-based pyramid and the angle between the base and any side is 55 degrees, all four of the triangles are going to be congruent, exactly the same as each other. So if we can work out the area of one of those triangles, then we can work out the area of all four of them. Now, because this is a 3D problem, we're kind of going to want to make some right angled triangles here, I think, because if we had a triangle like this, we know that this angle here is 55 degrees. We also know that if this is the centre where our right angle is, this will be 10 centimeters, which means that we could work out the vertical height, the height from the base up to V, using just SOHCAHTOA, because we've got a right angled triangle which looks like this. So we could work out this. Once we've worked out this, then we can work out this length here, which is the perpendicular height of one of the triangular faces. And once we've got that, we've got base times perpendicular height. So let's work out that. We're going to be using SOHCAHTOA because it's a right angled triangle. There was the right angle. Let's go with, this is the adjacent and this is the opposite, adjacent. So we're going to be using tan, and we are working out the opposite side, so we're doing tan 55 times 10. And that will be our perpendicular height of our pyramid. So tan 55 times 10, that's 14.28148,007. Let's save that, shift, store, let's wait an A. Now that we know that, we could work out this length here. Okay, and to do that we can use Pythagoras. Again, we've got a right angled triangle, so a squared plus b squared equals h squared. So y squared is going to equal 10 squared plus 14.2 blah 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 squared. There's the 14, so squared plus 10 squared. That gives us 303.9606729. Just in case, let's store that into B. Then we are, oh no, we're going to square root that, and then I'll save it into B. So y is going to be the square root of our answer. Which is 17.4344796. I'm going to store that into B. Now that's the perpendicular height, this diagonal going up here, of one of our triangles. So the area of a triangle is going to be 17.4 whatever times by 20 divided by 2. Which is 174.34469796. So therefore all four triangles equals 174.344 whatever times by 4. So that's 697.3787182. The base is a square, so that's 20 squared, which is 400. You can check that on the calculator if you don't believe me. And then so the total surface area equals 697.3 blah 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 plus 400, which is 1097.378718, and we want our answer correct to two significant figures. So that's going to be 1, and then the 0 is going to round up, which is 110 centimeters.